So if it's a log form and it's in a minus log form, do I ignore the minus? Do I ignore that?
Sort of, it becomes division.
The log form?
Uh-huh. Okay, so at the top of this page, you have the power. They have 4 exponential equations written below. A, B, C, and D. What do those 4 equations have in common?
There's x's in the exponent.
Very good. The variable's in the exponent. Or they have an exponent of x.
Oh, this one.
Now in part 2, they want us to rewrite.
Teachers, please pardon this interruption. This announcement is from Coach Vaughn. The softball tournament in Sonora has been canceled for tomorrow. Thank you.
Yeah.
Okay.
Okay, so they want you to solve these equations for x, and in order to do that, you have to rewrite them as logarithms. So I'm going to rewrite each one of them logarithmically. We've been doing this for the past several days, so this should be pretty easy. Remember, your base is your base. What was your answer becomes your argument, and your exponent is your answer. Now the question is, which of these 4, A, B, C, or D, could be solved directly with the common logarithmic function on my calculator?
D.
Common log, not natural log.
B.
B.
Never mind.
Because common log, so it's this one, is 10. So B. And right here on the summary, it asks you, the common logarithmic function on a calculator can evaluate logarithms in base of 10. It cannot evaluate logs for bases such as 2 or 0.8. So A and C, I couldn't, this one and this one, I couldn't do on my calculator with my common log button. It won't work. This one would. So, on problem 4, how can problems involving exponential equations be solved using common logarithms? If, when I rewrite it as a logarithm, it is not common log. There's a process. So, my first thought needs to be, anytime you see an exponential equation like this, your first thought needs to be to try to rewrite it with like bases. Because that is by far the easiest way. You remember, we've done some like that. But in this case, there is no way for me to write 20 with a base of 2. Because 2 with an exponent of 4 is 16, and 2 to the exponent of 2 to the exponent of 5 is 32, which means I jump right past 20, right? There's no way for me to rewrite 20 with a base of 2. So instead, the way that you would solve an exponential like this is to take the log of both sides. Or you are literally going to write the word log on both sides. So I'm going to write log 2 to the x equals log 20. Now notice, these are not bases that I wrote. 2 to the x is the argument, and 20 is the argument. I am doing log base 10. So I don't have to write the 10, because this is common log, so that I can use my calculator. Now this right here is the whole reason for for logarithms, because of this exponent. Well, what does the power rule say I can do with that exponent?
You take it out in front of the one.
Move it to the front. This gets moved to right here. So I end up with x times log of 2 equals log of 20. And that's because the rule says the exponents on the argument, so right here the x is on the argument, it's on the 2, that's the same thing as the power times the logarithm. That's why I can write it like this. I can just take that power and move it out to the front. That's what logarithms are all about. So now it's just an equation, because now my x is on the line with everything else. So now I'm just trying to isolate x, get it by itself. So what's with the x I need to get rid of?
Log 2.
Log 2, how do you get rid of it? divide. So I'm gonna have now x equals, so I'm gonna divide both sides by log of 2. And that would leave me log 20 divided by log 2. Now that right there is what's called an exact answer. If, those of you who are taking college algebra next year, when you get to the logarithm unit, it will ask you every single time for the exact answer, and that's it. But right underneath that it says evaluate, which means they want me to put it in my calculator and find the decimal approximation. So when I plug it in my calculator, you can either use the fraction bar and plug it in, so I could do alpha y equals, put the fraction bar in and put the logarithms in that way, or I can do log 20, but you have to close your parentheses. Otherwise your calculator thinks you're doing something different. So I put log 20 divided by log 2, and my decimal approximation is 4.32. So x equals approximately 4.32. Now right here on check, what they want you to do is take it and plug it back into the original equation. So I'm going to do 2 raised to the 4.32 power. And remember, I rounded, so it's going to be approximate. You didn't round. I get 19.97, so it's approximately 20. Is everybody okay?
Do we have to put the squiggly?
No, that just means you approximated or you rounded. I know you're rounding, so it's okay. All right, so let's do it again. So your first thought needs to be to try to write it with like bases. But there's no way for me to write 0.8 and 4 with the same base. So instead, I'm going to write log. I'm going to take the log of both sides. So I've got log of 0.8 to the x power equals log of 4. And the whole reason I did that was so that I could take this x and move it to the front. So I get x times log of 0.8 equals log 4. And now I need to isolate x. So I'm going to do that by dividing. So I'm going to divide both sides by log of 0.8. So my exact answer is log 4 over log 0.8. Now remember, these are common log, that's why there's no base written. And that's so that I can plug it in my calculator. So I'm going to plug in log of 4 divided by log of 0.8. And I get x equals negative 6.21. I'm going to check that just to be sure that that's the right answer. And it is. It equals 3.99, not equals 4. Everybody okay? Alright, so now on the next page, we're just doing this all over again a couple of different times, but before I do that, they want me to rewrite it as a logarithm. So the A box is just you rewriting it, rewrite this exponential as a logarithm. So this is going to be, remember your base is the base, so log base 6 of 104 equals x. And then I'm going to go through the process that we just did. So write log on each side. So log of 6 to the x power equals log of 104. The x gets to move to the front. And then you're going to divide. So I get x equals 2.59. Now if, when I had rewritten this logarithm, if I had rewritten the logarithm and it was log base 10 of something, I could have just plugged it in my calculator and it would have given me this. But it's log base 6, so that won't work. That's why I have to go through all of this process. So go ahead and do 6, 7, and 8.
Okay, wait, I just completely, wait, the regular for log is always gonna be 1.